Good evening, guys, and we are back with our problem solving of Thursday. And as you know, our this is our doubt clearing session along with some problem discussion session. So let's go and clear our students' doubts first. So yeah, good evening, all of you. Perfect. So let's get started, guys. Yep. So coming back to the doubts, Nikhil has already posted a doubt, but I think we'll do that after our IIT JAM this next year because it's of SLN, but it's a beautiful problem with the proof of SLN. But I think yes. So okay, so coming consistent estimator, I think consistent estimator can be done. Okay, so let's do this. This is our crash course problem. If you don't know about a crash course, please check the crash courses that we are offering. So it's a crash course from assignment problem, right, Tishika? This consistency.
Yes, sir.
Okay, so let's do this. Before that, let's start with the definition of consistent estimator. So we are already doing the a crash course where we have already started the sufficiency. I think we are quite okay with the sufficiency part, I hope. So this, as I have introduced the properties of estimators, the sufficiency is a small sample property, but consistency is a large sample property. So we have an estimator theta hat n, okay, which is trying to give a very close value to theta, which is dependent upon a sample size, and this is the sample size. The goal of n is the goal of theta hat is to get a close accurate value to theta, the actual parameter theta, right? So here, what we are doing is that we are trying to understand how good is that theta hat n. And to understand that, one of the properties is large sample property, which is the consistent estimator. Large sample property. Large sample means as n tends to infinity, something good happens. Okay, so there is a result that MLE, when n tends to infinity, the MLE like theta hat n MLE is a random variable, right? So there is a property that MLE theta hat and MLE, theta hat MLE, as n tends to infinity, it converges. It converges in distribution to a normal distribution. So it's called asymptotic normality property, but it's not there in the syllabus. I will not discuss per se, but just to give an idea that why this is one of the important properties that we look. And if you pursue some large sample theory, or if you have large sample theory in your syllabus, you must be seeing this kind of ideas going on your in your course. So anyway, so large sample property, one of the large sample property means large sample means as n tends to infinity, something really good happens. So the idea that something really good happens can be also denoted by probability convergence. That probability theta hat n minus theta, the distance between them is really small. Okay. As n tends to infinity, this probability goes to 1. Right? This goes to 1. Oops, I'm so sorry. Oh, it's being recorded in the YouTube, okay? So it's being recorded on the YouTube, so you will get that automatically from there. Yes, so a large sample property, one of the large sample properties is this. And what does it mean? It means that as the probability is of theta hat n being close towards theta is really large as it goes to infinity. So this is the large sample property, and this is exactly what it means by theta hat n converges in probability to theta, right? I hope all of you are comfortable with this mathematical notion, guys. I think we have taught you this in probability. All of you comfortable with this, guys? Shana, Arko, Dev, Mansi, Nikhil, Paulami, Pratiksha, Promar, Satej, Sriteja, Tishika, and Choprabha. Okay, Arko, welcome to Cheenta, and it's your first class with me, I guess, with us, I guess. So yeah, welcome to Cheenta. And if you, since you're new, if you're not okay with this whole thing happening, you can see the recordings, watch the recordings, and come back to us with your doubts. Okay, we will love to solving that.
No, it's fine. No problem.
Okay, perfect. So, so this is the large sample problem. This is what it means by theta hat n converges in probability to theta. So, if you want to practice some good good in probability convergence, you can use this large sample property. So one of the most important large sample property, and one of the most important also property of the MLE is that MLA converges theta hat under certain conditions. Theta hat n MLE converges or is a consistent estimator. That theta hat and MLE converges in probability to theta. This is a very important property. This helps a lot. Okay, this helps a lot in the sense that you will see often that some MLE plus. So this is another important property of probability convergence, that if xn x converges in probability to, let's say, theta, and y converges in probability to uh, theta, say, or let's say whatever, theta 1 and theta 2, then x plus y converges in probability theta 1 and theta 1 plus theta 2, right? You know this type of idea. So there is algebraic unlike properties of this improbability convergence. So we can use this to find more and more improbability convergence, like more and more consistent estimators. So let's use this property out here and check this. So often there are two ways of solving it. So I will tell you the algorithms how to solve the inconsistent estimator problems. So there is one way of proving improbability convergence, that is by computing. Okay, so one important idea by Chebyshev inequality is that if expectation of xn goes to theta hat n is goes to theta, and variance of theta hat n goes to 0, then by Chebyshev inequality you can show that theta hat n goes to theta in probability convergence. So one of the way of doing is this. Another way of doing is just compute from the basic principle. Often you will be able to compute theta hat n. Okay, so just compute probability theta hat n minus theta less than epsilon. Okay, I still remember in my ISI semester examinations I had to, yes, I have to compute this. I thought that maybe it can be done by this, but it was easier when you did this. Okay, the calculation was easier, because understand, you're here just calculating the probabilities. Okay, here you have to calculate the probabilities and you have to calculate the expectation and the variance, so it's double work over here. So use this when you know the distribution of this. Otherwise you can use this if you know the distribution. You can compute the distribution easily. So you can also compute this and show that this goes to 1. Okay, so this is a basic principal property, and the final property is that like theta hat MLE is consistent, and you can use this algebraic properties. So known results. So this is something I always told you about, that always use known results, just like you fall back upon the options of like when you see a PDF, you try to understand, okay, this PDF belongs to some distribution or not, some known random variables or not. Just like that, here you fall back upon the options that, okay, I know this is consistent, and we can use this algebraic properties, the properties of this algebraic properties to find inequality convergence. So using this three problem solving strategies, you can prove and use and solve. Using this, you can solve any improbability convergence and hence any consistent estimator. Okay, so using this, we will using the basic this theoretical background. Any doubts in this, guys? Any doubts in this theoretical background? Any doubts, guys? Any doubts? It's clear with all of you? All of you clear? Good. Okay, so these three strategies are the usual strategies. Okay, and I mean, this is what I have used in my life, not something more out of this. Yes, so yeah, most important is this one. It helps a lot sometimes. I mean, it makes it easier. So let's do this problem then. So x1 x2 xn is a random sample from theta to theta plus 1. U is maximum, the maximum order statistic, and V is the minimum order statistic. Okay, lovely. So let's do this. Let's find out this. So always try to understand. So there are two ways of doing this. Okay, do you want me to show the two ways, or do you want me to show the shortest way, guys? So the shortest way is that, as you know, like Yashu also commented in the on the YouTube live, that you can easily understand that theta has something to do with this. Okay, it has something to do with the MLE. So using that MLE idea, you can really do this do this problem. So let's check it out. So let's first compute the MLE. So x1, x2, xn follows uniform theta comma theta plus 1. So let's compute the MLE. So how do you compute the MLE? First, we calculate the likelihood. Likelihood x vector comma x given theta is nothing but the joint distribution. See, I'm writing this because in your ISI exam you have to write like this, okay? In your IIT JAM you can easily do it like this, but in ISI exam, which is coming really soon, also after IIT JAM, you have to write like this. Learn how to write mathematics. I was very weak at it, so I really focus on it. So yeah, so now they're IID, I guess. So of course they're IID, and I mean in the assumption, and let's find it out. So it's, if you understand, it's 1/1 only, but there's an indicator. It's indicator that x1 is less than theta plus 1 and greater than or equal to theta. An indicator times in all the indicators are there, so it's xi. And if the indicators are multiplied, you know that it's like all of them comes together. All of them must happen together. That means x1, x2 dot xn is less than or equal to theta plus 1 and greater than or equal to theta. Okay, and if this is less than or equal to theta plus 1 and greater than or equal to theta, let's count it. Let's do it. Let's find out that we have one condition over here that, okay, x, the minimum order statistic must be greater than or equal to 1. Also, we have another condition that the maximum order statistic is less than or equal to theta plus 1. Okay, because all these numbers means these two objects. Like if a set of numbers has some maximum and minimum, that it's same as telling that its minimum is greater than is equal to that minimum, and the maximum is less than or equal to that maximum. So like greater than or equal to the minimum, maximum is less than or equal to that maximum value. So that is exactly what we're using. It automatically implies this. Okay, it's if and only if condition. So we have that. We have the thing that it's equal to, therefore, indicator what, theta is less than or equal to x1 and greater than or equal to xn minus 1. Okay, and therefore this is likelihood, and let's draw the likelihood then. And if you draw the likelihood, you will get it, xn minus 1 is over here and this x1 is over here. So the MLE is turning out to be 1, and therefore MLE can be written as, MLE is not unique number 1, and MLE can be written as some lambda into xn minus 1, any one of this, plus 1 minus lambda into x1 is a MLE, lambda is less than or equal to 1, greater than or equal to 0. All of you understood this, guys? All of you understood this? Since you're doing statistics recently, that's why I'm asking you. Tishika? Good. See, you see how easy it becomes, statistics becomes, when you see you have a very good grasp on probability. Do you understand this, guys? Do you feel this, guys? I don't know if you feel this, but if you have a good grasp on probability, guys, statistics becomes really easy. So if you're having some issues with statistical concepts, that means maybe you are a bit uncomfortable in the probability region. Okay, so make sure you brush up those probability knowledge. And this is what I've experienced, because mathematics students has come into our course and learned statistics and probability from scratch, and we have devoted 6 months for probability and 3 months for statistics to work for them, 2 months for statistics. It worked for them beautifully, so I think it must work for you also from statistics background. You have an upper hand to that. Okay, so coming to this, this is an MLE, and by the consistency property of the MLE, for any lambda, like xn minus this is consistent. Okay, so also you can understand that xn minus 1 times lambda, but if you just write it in terms of this, you get that lambda times, okay, let's write it like this. Xn minus 1 converges to theta, and x1 also converges in probability to theta. Okay. So we have got that two extreme points also. And let's see. Is U an consistent estimator of theta? What do you think, guys? What is U? U is maximum. So is maximum a consistent estimator, guys? Tishika, what do you think? Yeah, is maximum a consistent estimator? So Shana, Orko, Dev, Mansi, Nikhil, Polami, Tishika, Pratiksha, Proma. So this is already told. Okay.
So let's write using the definition of consistency.
Okay. It's. Can you tell me? It's.
No, sir, I didn't get it as consistent.
Why didn't you get it?
Because it wasn't unbiased, sorry.
No, this is not an if and only if condition, Tishika.
The variance as well.
This is not an if and only if condition. If this holds, then it holds. But doesn't mean that if it probably this must be holding. There's something else. Like, I mean, use like the fact that if xn minus 1 in convergent probability to theta, then if you do plus 1, any constant, if you add any constant, that must converge in probability. So if you add plus 1 to it, it will converge to this. It will converge to theta plus 1. So xn converges to theta plus 1 in probability, not theta. You see it, Tishika. So use the properties. See, it is not, as I told, this is the most important property we use. The algebraic properties and stuff like that's the most easiest property. Okay, so what are the convergence in probability properties? Let me just check the give you the list of properties to you. I will just take it from Wikipedia because the comprehensive thing is given over there. A lot of properties over there. And yep, so let me just check that. Give me a minute. So this is one of the properties which is really important. Long one. So it just tells you the algebra, the normal algebra. Okay, and if if any sequence converges to A, then AN also, you can write AN as convergent to A in probability A. You can write like that. It's same. So just like that, okay? So did you understand, Tishika?
Yes, sir.
Section converges in probability to theta plus 1. So it doesn't converge to probability to theta. So therefore, this is not a consistent estimator. Is V a consistent estimator? What did you get? Yeah? What did you get, guys? Is V a consistent estimator? Tishika?
Yes, sir.
Yes, please reply. I mean, so it's a consistent estimator. Let's check the other ones. 2u minus v minus 2. So we have xn minus 1. We have x1. So check that. This is v, this is u, this is v, I guess. So 2u minus v minus 2. It's same as 2 into so 2u goes to where? Okay, I mean this is u plus this is theta plus 1. So 2u minus v, that goes to minus 2. That goes to where? You see 2u, that is 2 theta plus 2 minus theta. Therefore, it goes to 2 theta plus 1 minus theta minus 2.
Consistent.
It's consistent. Good. Let's check this. 2v goes to 2 theta and u minus 1 minus u plus 1 goes to minus theta. So both of their sum will go to theta. So therefore this is also consistent. Did you get it, guys? Oh, why I took that linear combination? Why to the linear combination? Because any point within this can be written as in this format. So all of them is a MLE, right? Linear combination means any point within this is an estimator. Any point within that can be written like in that format. Did you understand? Oh, because because that's the idea. Like, do you know convex? Like, how should I tell you that? Do you remember any point within this can be written as m by m plus n times this point, comma n by m plus n times this point. Do you remember that in your coordinate geometry? It's less than 1, right? And less than 1 means like it's, yeah, less than 1 means it's like, how should I say, it's, you can understand like it's the relative distance. That's the idea. Yes. Okay, all of you got this problem, guys? All of you got this problem clearly? Can we move to the next problem, next doubt? Did you understand how to do this, the consistency? Did you do consistency problem till now, guys? Okay, I'll be doing the crash course anyway. So yeah, me or the other faculty member, she will be doing it. So yeah, so there you can learn it. Okay, all of you clear with this, guys? Everything clear? Right, a boom. Okay, perfect, perfect. Very good. So let's move ahead to the next problem. Orko, are you understand everything? Are you understanding everything? Okay, so let's move to the next doubt Tishika has. Okay. Okay, I think this is interesting. I think this is a past year IIT problem. So they get a doubt from okay, so let's understand this. So first of all, it's asked whether it's unbiased or not. So let's check unbiased and then consistency will come up gradually. Um, how do you attack this problem from scratch? W is given like this, 1 by 2n square, summation of I from 1 to n, summation from j from 1 to n, xi minus xj whole square. Okay, fine. So you have to expand it out. So that means you have to find the expectation of this, right? So you have to expand it out. So let's expand this out, okay? Let's expand this out. A good way to expand this out is always writing in terms of xi minus mu, since you know mu, okay? So xi minus mu minus xj minus mu. So let's write, that's the basic idea. Always do that because that will help you in your calculations. Always. So you can just multiply. Okay, let's do that. So you have xi minus mu whole square plus xj minus mu whole square minus twice x1 xi minus mu times xj minus mu. Okay. And observe that if you multiply by sigma square, if you multiply by sigma square and divide by sigma square, it will help. Can you tell me what this term will give you guys? What this term will give you? Okay, this is over I and j both. So you can just write it together as I and j. Okay, what will this give you guys if you take an expectation? So expectation of sigma square by 2n square, sigma square by 2n square is outside, is summation, expectation of summation ij xi minus mu by sigma whole square plus xj minus mu by sigma whole square minus twice xi minus mu times xj minus mu by sigma sigma. I've written this intentionally. So can you tell me what this will turn out to be, guys? Can you tell me? Yes, we can standardize it to normal, right? You can standardize it to normal. You're right. Okay, I have missed a page over here. You can standardize the normal. You're right. So we have standardized it. So now you can easily understand. This is always a strategy. Always try to standardize stuff. Okay, standardizing stuff is also another important idea of statistics. It helps you in your computation, number one, and that's the general thing you want to do in general. So it's summation over ij. It's expectation of xi minus mu by sigma square. So it's expectation of, you can write it as zi squared, okay? Plus expectation of zj square. Minus, can you tell me what this will be, guys? Can you tell me what this will be? Anyone? Why this will be 0? Why this will be 0? Yeah? Standard normal mean? What does it mean? Tell me why this will be 0. You're telling this is 0 now. Why this is 0? Why this is 0? No, it doesn't make sense over here. Why this is 0? Like, I mean, this is a better. Tishika, why did you tell it 0? Sum of deviations from mean? No. There's xi and xj, right? So if you take expectation of this, what is that term? If you take expectation of that, what is that term, guys? This is something known term. When do you see this expectation of xi minus mu into xj minus mu by sigma sigma? What is that term? It's a statistical term. It's a statistical term. Correlation, perfect. It's correlation. So it's correlation of xi xj, twice of correlation xi xj, which is 0 since it is here IID. So it is 0, that's fine. So therefore you get sigma square by 2n square by summation, and all these are same. Expectation of xi square, zi square is what? Zi square is expectation of, zi square is nothing but variance of zi, is variance of zi plus expression of zi whole square, which is equal to variance of zi. So variance of zi is 1, so it's 2. Okay, summation of ij, so there ij is n square, so it's sigma square times 2. There are n squared such terms, so it's 2n square by 2n square, so it's sigma square, so it's unbiased. Did you get it, guys? Did you get it? It's unbiased. Did you get the proof it's unbiased? All of you sure? All of you understood that? Statistics is all about probability. I'm repeating again. So make sure probability basic is good. Okay. The reason you were not being able to, I don't know, did you able to, were you able to do this, Tishika? What was the issue you faced while doing this?
So I did a mistake in the expansion.
Okay. Okay. So yeah, so whenever you have this, remember these two things, normalize it, and always write it in proper format. That's it. Okay. So great. So let's see what we have to do in case of variance. Now we have to find the variance, right? So we have seen it's unbiased, and you remember the result, Tishika, like all students out here. Since Tishika is out, I am referring to Tishika. Tishika, did you understand that? Did you feel? Do you feel which result to use? Can you feel which result to use among the three results for consistency? Which result to use? What do you think? What do you think? Any ideas? W is an estimator of sigma square. It's unbiased. Yeah, any ideas, Tishika? Or any others? The mean variance one, right? So you already got that theta and expectation, the mu n goes to the mu. Okay, we already know that. We're already quite confident in that. Now we have to understand. Yes, if we can calculate variance and show that it goes to 0, then it's well and fine, well and good. So let's calculate the variance. But calculating the variance must be really hard. Maybe, I don't know. It's maybe hard. Okay, it's maybe hard. So is there a way around? So there are two ways to calculate the variance. If it's easy, or maybe finding the distribution. So finding the distribution, maybe you can calculate this variance. So can you find the distribution of W? Can you find the distribution of W? Can you find the distribution of W? Maybe we can find the distribution of W. Okay, so Satej had something to say. Yeah, we can understand from XI. Yes, we can do that, but how will that help? Okay, so Tishika and people told something that this will be 0. Let's see that. So I think that will not help. What you're thinking, Satej, is that this is normal. But then you're thinking of squaring it up. But squaring it up will only work, and we will find it chi-square only if they are independent. Some of independent normal squares are chi-square, not always. So we have to show the independence then, which is hard. So maybe you have to make it into a good format. So let's write this format down again. So we have this, that W is nothing but sigma square by 2n square summation over I summation over j, what, zi square plus zj square minus twice zi zj, right? This is what exactly we have. This is what exactly we have, right? So let's check that. Sigma square by 2n square. If you just do the summation of this over j, we have n zi square plus summation of zj square. We have summation of zj square j from 1 to n. Let's keep it like that. Let's call this C. Let's call this C. C is equal to summation of 1 to n zj square. Let's call this C. I think, yeah, let's call this C. And we have minus twice zi summation over zj. Now, can you tell me what is summation over zj? Can someone tell me what is summation over zj? Can someone tell me what is summation over zj? It's very easy. Already people have told this idea. What is zj? Zj is summation over xj minus mu by sigma. What is this summation? Tishika has already told this before.
Normal J.
No, this is normal 0 1 ka summation. Okay, you're right. If I was thinking of something else. Yes, am I doing it wrong? Maybe. Just give me a minute. Yes, I think I am doing a bit wrong. Not wrong. Okay, instead of this mu over here, if we would have taken this, so you have got it 0 over here, that's easy. But what if we would have taken this one? Can it be done like this? Just let me check. It could have been done like, just give me a minute. Let's check it out. I'm not sure. Let's check it out. Okay, let's check it out. So otherwise we have to do it in terms of x bar minus x bar. So okay, so if you check it over here, it's nothing but, again, if you just do the summation now, you will check that it's nothing but again n times summation I zi square, which is nothing but C. So you can write it as n times C plus, again, it's just constant C over here over with respect to I, so it's again n times C. So you get 2i's n C. Okay, and there you get a minus twice summation over zi times summation over zj. Okay, let's check that. So you get twice this, twice NC minus twice summation over Zi whole square. We have got that. So what we have got? We have got sigma square by n square, cancelling the 2. We have got n times c, that is n times summation over Zi square 1 to n minus summation over Zi whole square. This is what we have got. Okay. All of you okay with this calculation still now? All of you okay with this calculation still now? Yeah? Any doubts? I couldn't hear you if you do. Any doubts, guys? Shuprova, any doubts? Or did you
No, sir.
Shana, Dev, Mansi, Nikhil, Paulami, Pratiksha, Proma, Satej, Riteja, Tishika, and Shupravo. Everything clear? Okay. So we have got this summation. And okay. So we have to find the variance of this now. So this is a bit of a problem over here. In what problem? In what sense? I will tell you. We could have done it some way else also. So here, the variance is hard to get. The only reason is that here you don't know about the wait. Let me just think about it. Actually, that's good over here. Okay, something good is here. Okay.
So why couldn't we calculate the variance?
Maybe we will. I'm thinking a different way out.
Because covariance तो फिर zero correlation में कह रहा.
इसका zero correlation है.
नहीं, if we had tried the method we have used for unbiased.
No. Here there was an expectation. Okay, so here we need to find the. So the idea is that we are trying to find the variance of W. So we can find the variance of here. We can find the variance of this. The thing is that there is a covariance between this. Okay. The idea is that in exam you need to reduce the efforts. Okay. In exam hall you need to reduce the efforts. The best thing is that therefore is to use the known facts that if x1, x2, xn are normal mu comma sigma square, okay, then what are the usual consistent estimators of mu and sigma square? You understand? Can you tell me what are the usual consistent estimators of mu and sigma square? Do you know that? So that is the idea. That's what is not coming over here. That's why you have to continue it from scratch. See, as I told, we have to use a combination of these two. This is always the best approach. This always is not a good approach unless you can find some good. This is only good if you know the distribution of theta hat n. If you know the distribution calculated well. Okay, then only these are the two approach. Understand it very well. This problem solving strategy. Good approach means it takes less time. This is something that you already know, and it is easier to do that. And I will show you again with that respect. Okay. So now tell me, what are the good estimators? What is a give a consistent estimator of mu and sigma square? Can you give a consistent estimator of mu and sigma square here, guys? Tishika and all of you. Satej. S square is consistent. Very good. So x bar is consistent, and x and 1 by n. The ML is consistent. So 1 by n. This is also consistent. or 1 by n minus 1 is also consistent. Whatever it is consistent, okay? So you know this, right? So therefore, you have to try to break this up into functions of those. You see the idea? You have to, therefore, I instantly understood that what I was going wrong. Here we broke it up into xi minus mu by sigma. But here, therefore, you have to break it up into minus x bar. Why? Because it uses the third property that we want to use the fact that we know these are consistent. It helps a lot. I'm telling you, this is the biggest problem solving strategy always. I have told you in case of probability distributions also, we do it in terms of known facts, the behavior we know already. Here also the same idea. It's very obvious. That's how human minds think, okay? Human beings think. So we will use this property over here and try to break it up, the whole thing in terms of this. Okay, I just did it to show you that why it's hard. Because if you do a variance, we can find out the variance sum easily. Why? Because this is chi-square and this is I think this can be done in terms of, maybe it's also hard again, because you see variance of this will be required to find the fourth moment of summation zi, which is really hard to find. So this idea we have to drop. Whenever it's becoming more calculated, then there must be easier way out. Okay, always remember this in the exam hall. So remember this, whenever you think there's an easier way out, try to think, okay, is there something I'm missing? Is there something I could fall back upon? And this is the thing you can fall back upon always, by using the result that you always know, the theorems in per se. So remember those. And using those properties over here, you have to express W in terms of S square and X bar. So let's express W in terms of X square and X bar. So it's 1 by 2n square, summation of I, summation over j. So there we did what? There we did xi minus mu. Here we will doing this. xi minus mu ke jagah we will represent by x bar. Always. These are the two results always. Two ways of doing that. Minus xi minus x bar times xj minus x bar. Very good. And let's spread out. This is sample survey. This also helping your sample survey like properties as well. Sample survey practice, I mean. Why I'm using so wrong words today? I don't know why. Anyways. So if you sum it up, let's sum it up with respect to j first. If you sum it up, you have summation over xi, so it's n xi minus x bar whole square because it is not dependent upon j. Here it's summation over xj minus x bar whole square. And here it's minus. If you can see, if you can understand, this is where you need Tishika's idea. It's summation over j, standard deviation from the sample mean, which is always 0 therefore. So this is the biggest idea over here. There's always 0. Okay. And therefore this really helps a lot. And therefore 2n square. You see this is dependent upon this. So it's n times summation over I xi minus x bar whole square. Plus here it's n times. You see it's now dependent upon, it's a constant with respect to I. So it's n times summation over I xj minus x bar whole square. It turns out 1 by 2n. These are all two same, so it's twice summation over xi minus xj whole square. Both are same. So you get 1 by n summation over xi minus x bar whole square. You see now why it's consistent, guys? Do you see now why it's consistent? Yeah? Did you understand the ideas, guys? This sequence of thought process that went into that. So don't lose your hope when you didn't understand this. The reason is that you proceeded in the wrong way. The first approach is that always fall back on what you know. Okay? All of you understood that? Good. Did you like this idea? So remember, whenever you have a problem, always think about how you can, what are the results you know about the consistency and unbalanced and stuff like that. Why? Because you can use those properties while solving those problems. You can use those properties while solving those problems, and that's really useful. Okay, very good. So let's move on to the next problem. Okay. So we are last done sufficient statistics problem last time. Okay. Perfect. So let's try out this problem. If x1 follows normal mu comma sigma square and x2 given, oh okay, I think it will be given. There's a mistake over here. I mean, it's like it means given. And x2 given x1 is equal to x1 follows normal x1 comma sigma square. Find the sufficient statistics of mu comma sigma square. Good. Good. So find sufficient statistics of mu comma sigma square in terms of x1 and x2, of course. In terms of x1 and x2, of course. Okay. How to pose this problem, guys? Okay. Fine. You have x1 and x2, and it follows this. So how to find this? So how do you find a sufficient statistic? How do you find a sufficient statistic? Name and factorization. Always closing your eyes, name and factorization. Okay. Just that here you have to check in terms of name and factorization only. NP lemma. NFT, I'd call it. Name and factorization theorem. So now let's try to use that over here. X1 follows normal mu comma sigma square, and x2 given x1 follows this. So the question is that, can you find out so the first step is what? You have to find the joint distribution, right? Using the data you have to find the joint distribution. So can you find the joint distribution? Because that's the likelihood, that's the joint distribution. So write the joint distribution out here, x1 comma x2. You have to find the joint distribution, right? And okay, let's try to find the joint distribution out here. So it's f of x1 of x1 times f of x2 given x1 is equal to x1 of x2, right? So let's write it down. Let's write down it entirely, write it down. Some constant, or let's not write that. It's 1 by root 2 pi sigma exponential or e to the power exponential what? Half times x1 minus mu by sigma square. Very good. Times root 2 pi sigma exponential minus 1 x2 minus x1, observe this, by sigma square. All of you got this, guys? You have to first write, the first step is NFT. The name and factorization theorem is write the joint distribution. That's the first step. So do everything, whatever you have in your knowledge, to write the joint distribution. Yes, it will be square. That's the first step always. Close your eyes and do that always. Okay? Otherwise, you will not make any progress. Did you understand this step, guys? Now you have to write it down in terms of what it turns out to be. But did you understand that you have to write first joint distribution somehow by hook or crook? Did you understand, guys? All of you? Very good. Superb. So let's write it down now. So we have got this. So if we multiply this, we have 1 by root 2 pi sigma square times exponential. There will be addition over here, minus x1 minus mu whole square minus x2 minus x1 by sigma square whole square.
হ্যালো দাদা,
Yeah, hi.
বলছি একটু আগের স্লাইডটাতে দাও।
1 second. Also, please talk in English in the class.
আরে তোমার সঙ্গেই বলছি তো, কোনো অসুবিধা নেই।
No, actually, other students are going to listen to your doubt. No, that's fine. Anyways, I will go to the thing. Yeah, bolo.
হ্যাঁ বলছি, প্রথম যে ডিস্ট্রিবিউশনটা লিখলে ওখানে x1 মাইনাস মিউ এর স্কয়ার হবে না?
Oh, yeah. Thank you. Yes. Yeah.
ওকে ওকে।
Yes. So let's write it down. So what is the form of NFT? NFT is in the form of, remember, joint distribution means given t, x bar given t is independent of theta. So this will be, there will be one g of theta comma x bar or whatever it is, g of yes, g of t comma theta times, there's another just x bar, no theta. This is the joint distribution format. Okay, this is the no theta part. So you have to find out the no theta. So this is inside that. Remember, f is equal to g times h. H is the x part, and g is the h is the part which does not contain theta, in like free of theta. Okay, so h free of theta. So we have to find that free of theta part, and rest can be clubbed together. Okay, remember that. The first step is find that free of theta part. No, it's not h of theta. It's h of x. Because it's independent of theta, right, Satej? Yes, don't make this mistake. If you make this mistake, go back to the definition of sufficiency. That's what I did. I forgot. So I went back. So always you have the luxury to go back to definition if you know the definition. Therefore, don't mug up. I forget always. I'm a forgetful person. So exponential. So therefore, find what you have to do. You have to find divide into terms of something independent doesn't contain theta, and something that contains theta, and rest of the stuff. Yes, write it down. So it's half, it's xi square by 2 sigma square minus mu square by 2 sigma square plus x1, so it's 1, sorry, not I, x1 mu by sigma square. Fine. Minus x2 square by 2 sigma square minus x1 square by 2 sigma square plus x1 x2 by sigma square. Yeah, I hope everything is fine. Okay, good. So we have got what? So you see that find out something without theta. Is there something without theta? Is there anything without theta? No, everything contains theta. So therefore that hx part is 0. So this is the entire part, which is the main part actually. So 1 by 2 sigma times exponential So let's club this together. So what is the format? So it's minus twice AC, there are 2 xi, so it's minus of 1 by 2 sigma square times 2x1 square plus x2, and there is a mu by sigma part plus mu by sigma square twice x1. Right, did I take? Oh, there is another parameter part which get outside. It's exponential minus mu square by twice sigma square. This gets outside. So what we have? We have, therefore the function is what? This parameter ka function times exponential minus twice x1 square plus x2 square by twice sigma square minus or plus mu by sigma square x1, only x1, I guess. All of you understood this, guys? After this, I will come back to what is important. How do you find the sufficient statistics? But did you understand this, guys? All of you? Shana, Orko, Dev, Mansi, Nikhil, Paulame, Pratiksha, Proma, Pratej, Sriteja.
So can you move to last slide, please?
Sure. Yeah, everything fine?
Yes, sir.
Good. So therefore, this is a function of something. So understand that, if you remember, so you have to go back to the 2-parameter exponential family. So actually it's not 2-parameter exponential family, but yeah, you can understand it from here that if you consider these 2 parameters, 1 by sigma square, 2 sigma square, and this, uska sufficient statistics is what? 2x1 square plus this comma x1. This is a sufficient statistics for this, right? Because it's a function of this 2. It's a function of this 2. This is sufficient statistics for this. Right? You can also write it as 2, just sigma square. So let's see. What was the question? Yes. So now, if you remember, in that case, it was x1 square plus x2 square, and there it was x1 plus x2. So what is the sufficient statistics over here? It's actually a 2-parameter exponential family. You can understand this too, like have a 1-to-1 connection with mu comma sigma square. Okay. Like if you know this and this, there is only one mu comma sigma square pair. So if T1 comma T2 is sufficient for this, okay, then the 1-to-1 function of this, that is, so you can understand it's a 1-to-1 function. It's a 1-to-1 function. So that is also sufficient for this. So if you just do the inverse, that is also sufficient. And again, if you do that inverse, that is also sufficient. Did you understand that this is also sufficient for this? Because it's a 1-to-1 function. Once you know this, you know this. Once you know this, you know this. It's 1-to-1 connection. But just by dividing it, you get mu. And once you get mu, you can know sigma square. You already know sigma square. So therefore, this is a T1 comma T2 is sufficient for mu comma sigma square. Did you understand this, guys? This idea? This logic? Did you understand, all of you? Is it clear with everyone? So what is the first step? What did you learn from here? The takeaway is that always do dash in sufficiency. What is the dash, guys? Anyone? What is the dash? What is the dash? Find joint PDF. Perfect. Name and factorization and then find joint PDF. Joint PDF is the most important part. Okay, whatever condition and stuff is given. Find the core stuff, find the joint PDF, and rest will fall apart using a name and factorization theorem. You're right. Everything clear, guys? So all the doubts of today's class are over, I guess. Yeah. Okay, okay. So what else? What else? Is there anything that we have left? Any doubts, you guys? Any topics you doubt? In any topics you have doubts in, guys? Any topics you have doubts in? Okay, so I think we have not done till now radius of convergence, right? So let's revise the idea of radius of convergence. It's a very 30 minutes, 20 minutes, 20, 30 minutes idea. So I don't know, Suryanshi is not here. It was her doubt, but radius of convergence. So we will not do it again in our classes. Maybe we will do it in the mathematics crash course. So radius of convergence added in the new syllabus. Okay, so if we muse, okay, discuss your doubt. You have shared a doubt on WhatsApp. What doubt? What doubt? Satij? Which doubt? Please share it again, but I will do radius of convergence and complete it today, okay? So radius of convergence happens to power series. So what is the use of power series, guys? Power series is nothing but sort of, it's it comes from the infinite form of Taylor series. Taylor series gives still n plus a remainder term, right? So if the remainder term goes to 0, we can say the power series is convergent. Okay, so what is a power series? A power series is of the form. A power series is of the form this. A power series is centered at 0. This is the center of the power series. Is of the form summation of an x to the power n from 1 to infinity. This is the power series format. Okay, this is what power series is. Now, just give me a minute. Yes. So the question is that the power series has an idea of need to have an idea of convergence. For example, summation of x to the power n from 1 to infinity, this does not converge if it's only converges if x is less than 1, mod x is less than 1, right? Because it's 1 by 1 minus x. It converges only if mod x is less than 1. So the radius of convergence is that the power series always has a radius of convergence. That is, it converges only if x is less than this. That's the idea. So the core thing is that they may not it may converge at this is star, but it doesn't converge above this. Okay, so but it must always converge for this. So we have to find that R. We have to find that R. Can someone tell me why is it so that always it is of the form this? Because you can easily understand that if power series is convergent at x is equal to c, okay, then summation of an x to the power n, if you take the modulus, I'm telling about absolute convergence. It will be positive, and x to the power n. This will be if mod x is less than c, if you take this, then you can easily understand this is less than mod n c to the power n, which converges. So therefore, if there is a point where it converges, then x must converge for all the points here. So therefore, the radius of convergence, therefore the convergence must be of this format. Like there must be a point till which it will, at which it will not converge. So this is the idea. That means on this point, if there is a point at which it doesn't converge, then we will check the convergence just before that or after that, and at that point. If no other point is there, then the radius of convergence is infinity. We need to understand that the radius of the convergence region must always be of this format. You need to understand this idea. This is very important. You need to understand this idea. The radius of convergence must be of this format. You need to understand this. Because if there is a point where it converges, absolutely, all the points for mod x less than c, it will converge by the comparison test. Did you understand, others, all of you? Shayana, Orko, Dev, Mansi, Nikhil, Paulomi, Pratiksha, Satej, and Proma. It's very important. This is very important. Paulomi, did you understand? Mansi, did you understand? Mansi. Good. So therefore, the core idea of ours is to find the radius of convergence. So, how the radius of convergence is determined? That's the idea. And let's see that. So therefore, just give me a minute. Okay, there's only one theorem that helps you to find the radius of convergence, and that's it. So just remember that one theorem, okay? And I will not going to explain you what is that, but yes, so that's it. So I'm just going to state the theorem, okay? That's it. So why is that true? I can make you understand in some sense, but let's understand that. It's very easy to understand. I will just use ratio test. So this is the theorem that if R let's take the limit theorem of radius of convergence. How to find the radius of convergence? Let's take the limit that, let's assume that an is not equal to 0, okay, for large n. See, if n is 0 after a certain point of time, that means after a certain point of time all ans are 0, that means it's a polynomial, and polynomial is always convergent. So the radius of convergence is always infinity in that case. So therefore n is not 0 for large n, okay? So remember that. And it's also told that R is the limit. If R is the limit, n tends to infinity, mod an by an plus 1, you can easily understand this comes up from the ratio test idea. If this exists, either exists or it goes to infinity. Okay. If this exists, then the power series summation an x minus c whole to the power n from 1 to or 0 to infinity has radius of convergence r. This is the theorem. What is the proof? The proof is really easy. The proof is by um, the proof is by ratio test. Okay. And how do I keep you that? So let's not prove this. Okay, I mean let's not prove this. It's a very easy proof. I will apply this. Okay, let's apply this. And sometimes you can also find out by let's apply this. So let's do it with basic geometric series, summation of x to the power n from 1 0 to n. These are the radius of convergence, you know, 1, right? You know this is the radius of convergence 1. And how do you show that? You just calculate this. Here an is equal to 1, right? Here an is equal to 1. And if an is equal to 1 over here, observe that r is equal to 1. So radius of convergence is equal to 1. Okay? Radius of convergence is equal to 1. And yep. Okay, give me a minute. Just give me a minute. So I will give you certain examples. The example is this, that if you take 1 by n from 1 to infinity, x to the power n by n. Okay, so if you calculate r, which is equal to limit n tends to infinity an by n plus 1, which will be equal to again 1 over here. Okay, it's 1 by n and 1 by n plus 1, which will be equal to 1. If it's equal to 1, observe that it doesn't imply that always 1 it will be convergent. It means the power series is convergent for this, but you have to check at the end point. You have to check at -1 and 1. You're sure that at mod x less than 1 k it's convergent, but you're not sure about mod x is equal to 1 or -1. So always check that, okay? Here, if you put x is equal to 1, it's summation of 1 by n, which is not convergent. But if you put x is equal to -1, it's convergent. So its radius of convergence is the region of convergence is -1 comma open 1. So remember this idea. Not always it's convergent. Okay. You have to take that interval out there. That's very important. Which interval you take, you have to make sure which interval you're taking. So let's apply and do Suryansh's doubt over here. She has given some doubts last day, I remember, on power series. If px is a polynomial of degree d greater than or equal to 2, the radius of convergence of the power series is this. Of the power series is what? Pn. Px is fixed. Okay. So therefore, r is what? Limit. This is the an, right? The limit n tends to infinity. Pn by p of n plus 1. Can you tell me what is this power series, guys? It's very easy. Can you tell me just this limit? If Pn is equal to what? If Px is equal to what? If Px is equal to, let's say, A0 plus A1, let's start at A1, let's say P0 plus p1x plus p2x square plus dot 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 pm x to the power m. So it is what? It is pm n to the power m plus dot 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 by here it's pm n plus 1 whole to the power m. We are just only interested in the n to the power 1 n to the power m ka coefficient, right? So it will be pm n to the power m only plus something. So its radius of convergence is what? This goes to 1, right? Did you understand? It goes to 1. No, degree will not be n plus 1. It's p of n plus 1. Px is always constant of degree d. Oh, degree will be d. Okay, it will be d. Did you understand, guys? The idea. Did you understand, guys? All of you understood that? It's a very interesting problem. It's very easy. So this results comes from ratio test. Okay, remember this. This results comes from ratio test. Okay, very good. So let's do another problem. Suryansh's doubt. That's this. Find the radius of convergence of this. Z of n square. Yep. So how will you find this radius of convergence, guys? How will you find this radius of convergence? Any ideas? No. Okay, so that's the idea. So the proof is a bit different. So I am not doing the proof. It's like ratio test and comparison test combined. Okay, you can check the proof out there. So if you don't understand the proof, just ask me. I will prove it next day. Okay. Okay, so Satej, your doubt was actually discussed in the last class, Satej. Didn't you do the last class? The convergence of that limit Sn. I think that was Nikhil's doubts also that you have given posted. Okay. Okay, so how do you do this problem, guys? How do you do problems like this? When there is also 0 out there. So here we can use. No, see, the idea is that the radius of convergence idea, the result was only there if an is not greater than equal to 0, is not equal to 0 for large n. But you see here that an is 0 for large n. That's why these two doubts are like complement to each other, two questions. So what we'll do is that, you see, this is sort of like the geometric series. So let's understand this. So what does radius of convergence means? Means that if xn, mod xn is greater than something, this r, this diverges. Okay, and is less than r, it converges. This is what the radius of convergence, then only r is the radius of convergence, right? So what if we can prove it like that? So what if we just prove that, let's set r, what happens? You can easily understand that. Can you find a similarity with one of the series that you already know? Can you find a similarity with one of the series you already know, like this, with the same coefficients? Can you tell me another series which is which convergence you know? It's very easy. The geometric series. The summation of n from 1 to infinity modulus is always less than equal to what? Z to the power n. The summation modulus. Why? Because we are adding some terms, that's it. It's from 1, z to the power 4, z to the power 6, z to the power 9, z to the power 16, like this, it's all the z. Right? So this converges for, so therefore for mod z less than 1, this converges. For mod z less than 1, this converges, right? So we know that for mod z less than 1, this converges. Let's do mod z greater than 1. If mod z is greater than 1, you can easily understand there are infinitely many of them. The summation of mod z whole to the power n square is greater than what? 1, n is equal to 1 to infinity. Infinity times are there, so it's infinity. So it diverges for this mod z greater than 1. So the radius of convergence is 1. Did you understand the idea, guys? Did you understand the proof? Did you understand the proof, guys? So we have two methods out here. One is normal just calculation that has been shown. Another is knowing the definition of power series and what is the radius of convergence. That is mod x greater than 1 ke liye diverges and mod x less than r ke liye it converges. All of you clear with this, guys? Zero? What is zero, Satish? Oh, because for mod x greater than 0, mod z greater than 0, you cannot say it diverges. You can say it converges. We have to have both the conditions together. And radius of convergence is unique. You have to have both the conditions here. For your 0 case, it's convergent. For the greater than 0 case, it's not divergent. You understand, Satish? One condition you have satisfied. Sure. The radius of convergence definition is, another definition is that, like, it's the only definition is that mod x less than r ke liye it converges and mod x greater than r ke liye it diverges. Okay. So we have shown that mod z less than 1 ke liye, it converges by comparing with the normal x to the power k series. But for mod z greater than 1 ke liye, it means what? We have infinitely many terms greater than 1. So it's not convergent. For mod z greater than 1 ke liye, it's infinitely many terms greater than 1. So it's not convergent. Like mod wala. Did you understand China? So it diverges. That's it. And hence it happens that 1 is the radius of convergence. All of you got it, guys? So whenever you have a n is equal to 1 series, always the rate of convergence is 1. Because you can understand this. If it has infinitely many such terms. Okay? Okay, perfect. Good night. And we had a range of discussions today. I really liked it. And perfect. I think it was the best outline class as of now. Okay, almost all the doubts got cleared. One of the doubts got cleared. So perfect. So good night. And next Thursday, there will be no class due to Diwali. And the other classes will be there. Wednesday ka clan, Saturday ka. This next Thursday class will be like, like maybe compensated after in the next week. Okay, so good night, guys. Have a very good next weekend, and the assignments are uploaded today. Okay, all the best, guys. Good night. Yeah,
Good night.
good night. Looking for some crash courses and bronze course or mock tests for your IIT JAM preparation, ISI MStat, do join the WhatsApp group, and we are holding really regular quizzes so that it helps in your preparation. So join the WhatsApp group for your preparation. All the best, guys, and I will see you in the next class. Stay tuned and stay blessed.